So my name is Teal. I work with Associated Engineering. I have quite a varied background. I've worked with a general contractor for a long time. Now I've moved over to the design side. My intention today is to talk about leveraging model intelligence in bridge design. But first I'd like to ask quickly, how many people in the crowd are involved in bridge design? Just 2 people, okay. A lot of other people. I'm hoping everything that I talk about here today will have a broad application. And for each example, I'm really leveraging some of the experience that I've had on commercial buildings and institutional buildings and applying it to bridges. So I'll try and make sure that it's applicable to everyone. And what I'm really hoping too is that as I go through it, that this will be an opportunity to talk about kind of the nuts and bolts of applying the principles that we've talked about here today. So if you're with a firm that is interested in doing what's been talked about and getting started, I'm hoping that from this you'll be able to say, okay, tomorrow I have 2 things that I can do right now that are affordable and achievable to get started. So I'd like to talk about a few examples that I'll go through, and then I'd like to leave as much time for Q&A as I can, because I find there's a lot of value just in hearing other people's experience. As I'm talking about anything as well, if you'd like to add something from your experience, or if you have a question, please feel free to stop me, just to get as much value as we can with having everyone here in this room. So in moving from general contracting to the design world, it's been interesting to see things from both perspectives. I do find now there are a lot of times I'll be in a design session and be thinking about the superintendents I worked with and what they would say if they were there, and just anticipating the cursing that I'm going to hear once what we're talking about gets out into the field. It also gives me a much better sense, too, from the design side, why things are the way they are. And so it's been interesting approaching it in that way. And one thing I've really noticed that when it comes to modeling, it's quite different on the bridge side, the design side, as opposed to building information modeling. When we're talking about bridge modeling, we're talking more about the analytical structural analysis. And we're thinking about nodes and members and cross-sections, rather than looking at objects and geometry and data fields. And so what we've been trying to do at Associated Engineering is to incorporate more of that building information modeling approach and really leverage that in our design process. So everything that I'm going to be talking about here today are examples where we've done that in design, but it has not gone into drawing production. All of these examples have just been in our development of our designs to better understand what we're doing, better collaborate as a team, better communicate with the contractor, and in the end try and produce a higher quality deliverable by leveraging the power of these technologies. So I'd like to talk a little bit about some of the challenges involved with geometry modeling for bridges in particular, with some of the tools that are available that in their native form are geared more towards buildings. But really this would apply to anything with really challenging geometry, which I know we see frequently in buildings as well. I'd like to talk a bit about reality capture, which is it's a fantastic way to get started in really achieving the value that can be seen from applying the principles we've talked about today. And then I'd like to talk about just the development of those models as we get into more, get beyond just the geometry and get into more of the data that's going to add value throughout the process. So to start with, I'd like to talk about reality capture, and in particular 3D scanning and photogrammetry. And I know from a number of people in the room that I know, quite a few people have experience with 3D scanning. Quite simply, they have a scanner that looks like a total station. They set it up, and it fires out hundreds of thousands of points, collecting the data to create a 3D point cloud of the built environment. You can then bring that 3D data into your design environment, so this digital representation of the as-built, and you can start to work from that, just straight from the point cloud. This image here is from the Southwest Anthony Henday in Edmonton, and they're going to be widening it from Calgary Trail to the White Mud. So for anyone in Edmonton, I recommend staying away from there for the next 2 to 3 years, and I apologize for how painful that is going to be. But in this case, what we were able to do is get a 3D scan of the bridge crossing the North Saskatchewan River. We were able to bring that into Revit. And so right at the start of our design, where we had to widen the existing structure, we were able to start from a very thorough understanding of what was actually in the field. And we found this added a lot of value compared to just a traditional survey, because anything that you can see in that 3D point cloud can be measured. And in Revit, you can cut a section, you can cut an elevation anywhere that you want, and anything that you can see, you can get a coordinate, you can get an elevation, you can put it onto a drawing, or you can use it just right in the 3D. And you don't have to create solid 3D geometry to get that value. You can work just straight from the point cloud. So that means if you go to a company like Challenger who's there, one example I'm going to show right away is just from a small sole proprietor in Edmonton. You call them, just say, I'd like a 3D point cloud, I'd like it in a PTS format. When they give it to you, you can get it into Revit, and you can start working with it right away. It's very achievable and adds a lot of value. This is an example where we did exactly that. This is a bridge near Entwistle, just west of Edmonton. We had a contractor who had done some milling on the surface of the bridge, and they were getting pretty excited because they started to see rebar. And the first thing they said is, it's not our fault, the rebar's in the wrong spot. So what we would normally do is we would send someone out with a straight edge and a level and a tape measure, and they would have to go and lay the straight edge from side to side along this milled surface along the lane, and they would have to measure down at various points to try and get a sense of what that surface was looking like and whether it deviated from what we were expecting. So instead, we called, and I'll give a shout out to this company, it's Site BIM in Edmonton. We said, can you go out and get us a scan? And he was able to do it in an afternoon for $1,800. That included travel time and everything. And then using a free open source program called Cloud Compare, we were able to pull in our civil 3D surface that defined the final road surface and compare each individual point to that surface to see if the milling was done according to what it was supposed to be. So you can see on the right there in that image, anything that's red, they milled too deep. Anything that's blue wasn't deep enough. And as you zoom into there, you can see right down to individual ridges in the milling. And so that gives us absolute confidence of what's out there, what we have to work with. And it helps us immensely when we're talking to the contractor and saying, okay, here's where we're at and here's how we know that. Again, what I really want to emphasize is this is just the start of really incorporating these digital tools into your workflow. This was cheap, it was quick, and added a lot of value just right off the bat. Another example of the reality capture that we're incorporating is photogrammetry. And for anyone who hasn't heard of that, it's basically you take a bunch of photos, program automatically stitches it together into a 3D model, and that 3D model has a photographic skin of whatever you were capturing. For anyone who's looked at Google Earth, that's how they get their 3D buildings. They just fly a plane back and forth, it takes the photos, it just stitches it together into 3D. The more photos you get, the more accurate your 3D surface. And in this case, what we were able to do is there was an exposed concrete structure. A company came out and did a scan for the rebar behind, and they painted onto the concrete where they found rebar. And so using an iPhone and $50 a month software, I just went out, I took about 200 pictures, fed it into the software, and it spit out a photographic 3D model that we could then take elevations of and include that in our assessment. And so you could actually see the photograph that captured all of that in there. And again, it was literally just with an iPhone and $50. So this added a lot of value in just making sure that we captured everything that was existing in the field and being able to communicate that to our clients in a way that gave them a lot of confidence that we really knew what was going on. And we could do it multiple times as demolition and repair progressed. So again, very, very easy to do and added a lot of value. As you progress with the use of the modeling, you can use tools like Revit and Civil 3D to model the bridge geometry and superimpose that with the 3D scan. And so in doing that, you can come up with a very detailed variance analysis. And this could apply as well to complex geometry in buildings or really any structure. If you've got the 3D point cloud, if it's georeferenced, and if you have a separate 3D model that is also georeferenced, you just bring them together and you start to cut sections and see how they line up. In this case, this is again the Southwest Anthony Henday. We made a model based on the as-built drawings that we had. We had the 3D scan, and then we just superimposed them in the same coordinate system, and then we started to cut sections and then measure where variances were. And this added a lot of value, again, in just making sure that as we're trying to tie into this existing bridge, we're tying into the right spots, and that what's out there is actually what we're expecting, so that we don't get RFIs that say the elevation wasn't what we thought, what do we do now? So there was a lot of value, and it didn't take a lot of effort on our part. And again, as we're modeling it, we weren't worrying about what the drawing production process was going to look like or what the client wanted. This was for our internal use, and we found it was worth the effort of putting together the model. And we found that even though Revit isn't designed to model a bridge like this, there are ways to use the native Revit tools to put together the bridge model. And that's true for other complex geometries as well. And I know there are other tools that are out there that handle complex geometry to a greater or lesser degree. But what I wanted to emphasize here is with tools that are readily available and relatively easy to use, you can jump in and start doing this sort of thing right away. As I moved from contracting to the bridge design, one thing I found is what scared a lot of bridge designers away is that because these tools aren't designed for bridges, they're designed for buildings, sometimes getting them to work can be a little tough at first. Anyone who's used Revit knows that it's not great with curves. So when you've got a bridge that is curved horizontally, vertically, and has a super elevation, it can be tough for Revit. But there are tricks that can be used to get past that. In this example, I'm showing a corridor that was taken from Civil 3D, put straight into Revit. You can't cut a section through it properly. But if you take that corridor, put it into a Revit family, and that Revit family into Revit, then it works. So little tricks like that can get you past those roadblocks, and all you have to do is go to YouTube to figure out how to do that. YouTube is incredible. There's nothing that you need to do in Revit that you can't learn on YouTube. So, if you've had that experience where you hit those roadblocks and you're kind of stuck and you don't know what to do next, just go to YouTube and you'll get past it. So in using those techniques, we really found that there's a lot of flexibility in the interoperability between programs that are used for the road design versus the bridge design, and we have to work really closely with them. This is also true with commercial buildings. If you need to get roadways in there, if you need to get landscapes, things like that, there are a lot of options for how you can swap that information back and forth. And again, all you have to do is go to YouTube and you'll figure it out. So if there is any kind of roadblock that has been keeping you from getting there, or as you hear some of these principles talked about and you're thinking like, how do I get from where I'm at now to where I need to be to start to really realize some of the value that we've been talking about here today, you can get started right away. Just get a scan, put it into Revit, and as you hit those roadblocks, just go to YouTube. And that's all it takes. And I know it sounds almost stupidly easy to say, but I've found so many times as I've talked to people in the field as a general contractor, whether it's a subcontractor or anyone involved in construction, a lot of the times they say, I tried the 3D thing and it didn't work, and I'm done. And it's understandable that as you hit those roadblocks, it just gets frustrating, and you just want to get it done, and your budget is getting burned up, and your boss doesn't care that you're trying something new. They're just looking at the bottom line. It's understandable that can really keep people from taking those steps to get there. And part of what I really wanted to emphasize here today is that it is very achievable. Oh, sorry, yes. That's a good question. So for anyone who couldn't hear, given the time and the resources needed to accomplish this, how do you communicate that to your client? And basically making sure that they understand what will be needed to get to the end product. Is that right? I think that really varies from project to project and the anticipated deliverable. In the cases that I'm showing, this was our internal project team. And they basically said, you can do whatever you want as long as you get your work done in the budgeted time. And so to be honest, in that case, I didn't tell them anything. And I've had instances too where I've said, hey, I could do this in Revit, I could do this and this and this. And someone on the project team I'm working with says, that sounds expensive. Don't do that. And so I kind of say, okay, I won't do it. And then I do it anyway because it helps me get to what they want. And I don't know if anyone else has had an experience like that where literally this is the easiest way to get to the deliverable. And so in a lot of cases, you don't have to tell your client. They don't care, how you get from A to B. And if this can't get you from A to B without asking for extra time, it might not be the right solution. So I hope I'm not, I feel like that almost sounds dismissive, and that's not my intention. But I'd be interested to hear maybe, too, if anyone else has experience in that. But I found if you have to justify it, you might have to rethink that process, because you don't want to be doing this just for the sake of doing it. If it's not going to get you to the end product better than you could traditionally, then don't do it. And so it really depends on the situation. I feel like there must be a better answer than that, but that's the best I've got. But I have had a number of instances where I've had a project manager, when I start talking about all these cool things that I want to do, and they're just seeing dollar signs, and they've said, don't do that. I'm not paying you to do that. I'll say, okay, that's fine. And then I do it anyway, and I only show them the end product, which might be a PDF, and they don't know how I got there, but I got there better. And I found that that's been pretty consistently the case, and these are good examples of exactly that. So I just want to... So as we're developing these models, we're kind of moving from just working on geometry and just working on really simple problem solving. But as it grows in the complexity, that's when we start to get into the data-rich models that people have talked about earlier today. And when you get to that data, that really takes it from the individual project to the bigger picture. And I think as you get more and more comfortable using these tools, I've really found you'll want to pursue the more data-rich and that deeper level of modeling. I really got started using SketchUp. I don't know if anyone here is familiar with SketchUp. I love SketchUp, and I really loved SketchUp at the beginning of my career. And I used to argue with people who were like pro Revit. I'd say, anything you can do in Revit, I can do in SketchUp quicker. And often that was true. And eventually I got to the point, though, where I wanted to query my SketchUp model. And for things like volumes and stuff, that was easy enough. I found ways to make survey points in SketchUp. But as I wanted to get more, deeper and deeper into it, SketchUp was a solid modeling program that didn't have the capacity to attach all of the data that I wanted. When I wanted to start querying that model for intelligence, it just wasn't there. And that's when I finally realized really what Revit is trying to get to. It's not just about a nice 3D picture. It's about that data in the background that you can really leverage. And that's when I really started to think about modeling more as data visualization than just visualization. And I'll get to an example here right away, but this quote by John Tukey, who apparently is acknowledged as one of the fathers of data visualization. He says, the greatest value of a picture is when it forces us to notice what we never expected to see. And I found that's been very, very true as I start to query the intelligence behind a model. This is one example of that. So this is an abutment on the Southwest Anthony Henday. As I modeled the portion that we were going to be adding on to widen, I applied material types to each portion. And by doing that, Revit can automatically query the quantities and can separate it by material type. And this is something that our client, Alberta Transportation, really wants to see. On their drawings, they want to see how much high-performance concrete is there, how much Class C. They want to see how much black reinforcement versus stainless steel reinforcement. They want those quantities shown on the drawings, and they need to be accurate because that's what's going to be going out to tender, and they don't appreciate big busts between your estimate and what comes back at tender. So as I'm building the model in the design process, I'll model up my abutment and get the geometry. I'll start putting in rebar, and I'm not doing that for the documentation because, again, this model never went to documentation. This is just for me to understand where's my rebar going to go, does it fit, do I have the development length? And as I'm adding it, I start to notice areas where my two details are meeting at a corner, and I'm going to need another detail to manage that corner. And that's where, for me as a designer, it really added value because I'm realizing that now in the process and not from an RFI when the guys in the field are cursing at me for not anticipating what to them is absolutely obvious. But as I'm doing that, because of the intelligence in the model, my rebar schedule is automatically just being built. Every time I stick a piece of rebar in there, my schedule detects it, it counts it, and it puts it into a table. And the same is true with the quantities. So in this case, at the end of the job, I had a table that showed all my quantities, and anytime I clicked on an item in that table, the model elements that were supplying quantity to that table would highlight. So when people said, did you remember the 300 mils of HPC at the top of the back wall? I can click on it, and it highlights, so yes, I did. And when people are reviewing my work, it makes it that much easier to do because they can visualize everything that's in the table. In this case, part of our QA process is someone else does the numbers separately. In this case, someone did all of the quantities in Excel, and I had done mine in Revit. And we had about, I think, a 2% difference on this abutment. So I said, okay, well, let's figure out where our difference was. And I clicked on my table, and I said, okay, here's all my HPC. Where's yours? And they had this big, long Excel spreadsheet where they had calculated things out, and they couldn't sort it out. In the end, they couldn't say where the difference was. Whereas with mine, it was a simple click because it was querying all of that data that was already built in. And in the end, the other person was 2% higher, so we just went with their number because that's more conservative, which we like. So this is just a really simple example how even simple geometry modeling with simple data can start to lead to a model that can be queried, and then all of that intelligence is adding value. And this is just in the design process. Again, the clients never saw this because for anyone who works with Alberta Transportation, or I think in bridges in general, often in construction, people sometimes maybe are hesitant to accept innovation, and often they're just used to doing it. With bridges, it's doubly so. In a building, structurally, you've got a lot of redundancy. Like if this column goes, it's not good, but the rest of it will flex. It'll take a little bit before it all comes down. If a bridge girder goes, you're done. Like that's it. Alberta Transportation does not like change. We still have to sign Mylar and send it to them because that's their process and that's how it's going to be, and that's it. And so on this job, we knew they would never see this model, but it still added value. Querying the data helped our design process, and hopefully down the road, we'll be able to come up with a process where Alberta Transportation will be able to take my model and do their checks just by querying the data. But in order to do that, we're going to have to really collaborate. I'm going to have to name things in a way that their system can pull in. And some of the systems we've talked about here today, you would need that collaboration. So just by starting with the simple things that we've talked about, like 3D scans, will get you started on that road where you'll have a good intuitive sense of what's going to be needed in the steps along that process. So when your client says, okay, I've decided I want your model, you'll know the key questions to ask. So you won't just say, yeah, no problem, we'll give you a model. You know to ask, okay, well, what data do you want attached to that? What do you plan to do with it in the end? And how do we make sure that our intelligence feeds into the value that you want to see? So we can avoid those situations where someone says, well, I asked for a model, I thought I was going to get the matrix, and instead it's just this picture that I don't know what to do with. Everything I've talked about here today are those first steps. And again, I was really hoping that what it would do is for anyone who's getting started in that or partway through the process, to give them some of those first steps that are achievable, that add value right away, and that will help you incrementally work towards the kind of principles and value we've talked about here today. Does anyone have any questions or comments that might help just kind of achieve that for everyone here? No questions? Everyone's hoping they can get back to the shrimp before it's all gone. Okay. Well, thank you very much, everyone, for your time.